So just wanted to introduce this topic and say, been in GIS profession for a long time, and as GIS technology grows and evolves, so do we as professionals need to grow and evolve. And it's a constant challenge, I think, for everybody to keep up with technology. It's real easy to get complacent and do what you do, but the technology just keeps evolving so quickly. And I think it's the most important thing is to keep learning. And as last presentator just was talking about, you run into problems all the time, and you have to come up with solutions. And our particular example, making it work, that's what happened here. We had a project in mind we thought was going to be pretty straightforward, but you always run into some stumbling block. You have to figure out how to make it work. And we're also talking about programming, the SQL trigger-based replication for database synchronization with collector ArcGIS data. A lot of words there. This co-author was Mike Zada. He's a local Washington software engineer, programmer, but he was unable to attend today. So anyways, we'll talk a little bit about the background of the project work and what we did and how we got started on that, the project vision and some of the goals we had with this project when we first started out. Then we'll look at the GIS part, how the GIS was implemented, and then how we came up with some of the solutions to correct those problems. And also looking at unifying GIS and the SQL databases, and we'll talk about why that was necessary and how that worked, and then look at a little overview of the project. And this is really a technical presentation, so I don't have any flashy pictures or drones or anything to come in here, so bear with me, please. So a little bit of background of the project. It primarily started out as a migration of Access data over to an SQL database. Originally, there was several Access databases that were independent, rogue databases spread out through the organization. They were maintained by various people. They were built by various people. And the data was hard to access by others. To get data to the clients was, a hard drive or flash disk or something. There was no direct communication. So the idea came up to, let's move it on to an enterprise SQL database. So at that point, the GIS group realized that there was an opportunity to, unify the database with GIS. And that's really, was really exciting for everybody to that potential to unify those two things. And then developed a project team that was comprised of management, IT, GIS. We brought in a programmer to help with some of the programming, and also the users, the most important part. So they played a huge role in understanding how the current database was being used, the things they liked and didn't like, and then things that they would like to see with the new database. And originally, the IT department took control over the migration from Access to SQL, and they kind of developed, took a waterfall approach, doing a chunk of work, getting that done, then moving on to the next chunk of work. And due to some time constraints and money, decision was made to maintain the Access schema of the data. So the original schema of the database and Access was going to be maintained, but moved into SQL, just mimicked, and then the front end, the Access front end was going to be repurposed for the SQL database. And then another thing to consider too was the GIS group really wasn't fully engaged in the project until after the database migration to SQL. And so the project vision really for us, we saw like I mentioned earlier, the opportunity here to unify the enterprise SQL with the GIS database. So that was pretty exciting. That would give us a single managed database and give us a common attribute schema too. Originally, the GIS was really independent from the database. So we had a database in Access. The GIS had its own independent database being maintained. The schema was different. The information was similar information, but they were both independently maintained. And by merging the two, it would obviously give us an opportunity to, have a singular managed database with common attributes. To simplify the data input into one area. The maintenance, the backup, security, and storage, all these things would be really simplified and localized into one system. And the other goal too, through the project, we had an opportunity to implement an electronic data collection. Previously, everything was done on paper forms, you know, taking notes out in the field for paper forms. And a lot of this work was being done, you know, the pre-drill, pre-mine inventory work on people's properties. And the data could be then entered directly into the SQL, and this would reduce, you know, a lot of the cost and time that would take to enter the data into the Access front end like it was before. And it would help, you know, meet the cost-saving needs of the client. So, just like the picture says 1,000 words. So, we start out goal 1, you know, after the Access database was migrated into the SQL. It was the GIS turn to step up to the plate. And so the first thing we were planning on doing was to create a spatial component by geo-enabling the SQL database. But right off the bat, boom, there was a primary key constraint. So what happened there is in SQL, the old Access attribute schema was such that the primary key was already taken, so you couldn't just directly geo-enable that database. So we had to be creative. We had to come up with a solution. We had some meetings. We brought in some other consultants to come up with some options. And ideally, you know, if we could have written the SQL attribute data to just be a GIS database, that would have been the ideal solution, I think. But that wasn't on the table. There was too much work already had been done and time spent on that. So it really highlighted the need for, you know, more rigorous testing prior to implementation of the project. That's lesson learned, you know. So the GIS solution started out, we decided to, you know, the next best thing to a unified database would be a replica database. So we started by going into the SQL database tables and making replicas of all the features that were in there for the parcel inventory. And some of the common things that were in there were like wells and piezometers, springs, ponds. There were some line data streams and polygons. And there were a lot of attachments like other folks were talking about. There was a lot of tabular data and attachments, but those, at this point, those weren't being considered as needed to be brought into GIS right at the front. So we just focused on the feature classes. And the other thing we had to do to make this all work was we had to assign all the feature classes a parcel ID number. All these features were within parcels, you know, and every parcel was unique. And also the name of each, for instance, if it's a well, there may be 5 wells on a property, but each well would be, you know, have a different name, well 1, well 2, well 3, whatever. And along with the parcel ID, that provided that uniqueness that we were really needing in GIS. And then we also had to add that parcel ID field into the SQL database table too, to keep everything having a common attribute to work with. We also converted all the coordinate system to Web Mercator because we knew down the line we were going to be looking at the collector app and going into that solution. It makes it a lot easier to publish maps using map projection. We also, at this point, had the opportunity to do a lot of QA/QC on the old data because a lot of the data was hand-entered. You know, it was coming off paper forms, being then hand-entered into into those Access databases. So there was a lot of, you know, there were errors that were there and back coordinates, duplicates of records, and things like that we had at QA/QC. So that provided an opportunity at that point to do that. And this is just a, you know, I had to put some kind of something else in text. So. It just shows, you know, the parcel ID field being unique and, you know, attaching to the database. So the goal 2 was to utilize Esri Collector app. So we decided to use the ArcGIS Online rather than to try to deploy a portal at that point, just to simplify the development and, the deployment. Purchased a bunch of iPads so we can you know, collect data in a disconnected environment, and had to get ArcGIS Server Enterprise also to publish version data with the same capability and to work with the Enterprise SQL. So that so there's, you know, some cost involved there. So also, you know, the reason I wrote this up as I did too, I was like last year we had a lot of students in the audience, and I try to put this together so if a student wanted to look at some of the steps that all this you have to take to get this to implement, they would have a little bit of, you know, have that information in front of them. But a lot of you have been working with collector apps, so you know how this goes. You know, you have to, one of the first things we did was looking at the paper forms that were being used out in the field. So those paper forms had a lot of information on them, but so we were able to take all that data that was in all those paper forms and use that to populate our domain drop-down values. And then, of course, you have to construct a map of all this data and then analyze for publishing. And I think Jim yesterday mentioned about, you know, publishing maps to ArcGIS Online. It could be a, you know, a process in itself. There's a lot of things you have to be concerned with as far as, you know, projection issues, database registration, the tables. There's all these things you're going to go through. You're going to have many hours talking with Esri on a lot of stuff to get it all to work. It's not, you know, as straightforward as it seems sometimes. And you have to publish the, you know, the map service, feature map service with sync capabilities. And then from there you upload it to ArcGIS Online, create a map on ArcGIS Online. You have to allow the editing capabilities. And you have to create edit groups, so you have certain users that are going to edit that data, so you want to allow them to edit it. And then also, when they open it on the collector app on iPad, they can you know, be in a disconnected editing environment at that point and do their field work. And this is just a quick screenshot of, you know, some of those, you know, publishing the feature access. You have to make sure you have the sync capability marked all the time. When you go onto ArcGIS Online, you just edit the item from the web, so you have to give it your REST URL, URL of the data of your REST services, and it comes right into ArcGIS Online. And that process actually worked pretty well there. And then once you have it on ArcGIS Online, you could start looking at you know, your data online. It's being served from our, you know, the local server there, so that worked out pretty well there. And so the last part of this thing was to get the GIS and the SQL databases to be unified. Even though they weren't one database, the unification being synchronized was very important. And again, like I mentioned, we talked about this in the best scenario, best cases to do this, and we came up with this SQL trigger mechanism to sync the GIS with the legacy SQL database. And I never worked with triggers before. You know, I knew they were out there, but it was very interesting to you know, look at some of the other people that had used this for other different applications, and we felt it would be a, you know, possible solution to what we were working with. And one thing about the trigger, they would only activate upon the database compression, and I'll go into that a little bit more in detail here in a minute. And the data would flow from the GIS, collected data into the legacy SQL database. And one other cool thing was that from the SQL database, we were able to write back into the GIS also. So that was a, you know, kind of a two-way street. So it was kind of a really good, because the SQL database itself was maintaining the primary key information. Every time a feature was created in the Access database, it generated a unique number for that record, and that record had to be put back into the GIS. And then the trigger did allow for you know, new data input, edits, and updates to existing data, and it also allowed for deletion of records. So that was pretty cool. So these next few slides were from Mike Zada. You know, he came into this project as strictly pretty much of a DBA, you know, programmer, SQL person. He had very little experience with GIS, so he really learned a lot about GIS going through his project. And you know, so the database triggers were created to, you know, to provide that continuity between the legacy database and the GIS database. And the triggers, they were residing on the GIS database on the feature class base table. And I'm not sure if everybody is with SQL, but we're going to talk a little bit more about how those tables are structured in a minute. And there was two triggers written for each base table. There was an insert and a delete trigger, two different operations. And there was no update trigger was required, because the SQL never issues really an update command. The way they handle it is that they actually it deletes the row of information first, substitutes a new row, and then updates that information. So it's kind of a, you know, on the programmer side, you know, Mike saw that as very interesting, you know, and it was one of those things that, he was able to deal with the code. And he said because of the unusual behavior, he had to include logic in that insert command to account for that operation and be able to write back to the database table. Of course, we're using SDE version data, and then when you do that, the version data sets up the delta tables, so you have the add and delete delta tables in SQL. And so when you apply edits to the base table, SDE will execute the insert or delete to reflect those changes. And if you make a change in GIS, those changes are actually first shown in the add and delete tables. They don't go to the base table directly. So you have those add and delete tables in SQL that are holding those new changes to your records. And one drawback he also found to that was that the integers, text and images and a couple other binary data types weren't able to be manipulated by the trigger. So that was a little bit of a drawback, but for what we were needing it for, it really didn't affect us very much. And again, since those triggers resided on the base table, we had to perform a database compression to get the triggers to fire. And we'll talk about that a little bit more too. And and if the database in GIS was ever deleted, if you deleted the feature class, those triggers would have to be recreated. So that was something to think about or be concerned with. And again, the whole process, was pretty straightforward. So, each map was downloaded onto an iPad device, and every time you did that, it would create a new version of the data. So if you're using, iPad right now and you download a map, it creates that version for you. So the field crews would go out and collect the data in their collector app. And since the data was being served from the local server, when the data was synced back to the ArcGIS Online cloud, it would actually be syncing back to the server at the same time. And this allowed the GIS staff to perform a QA/QC on the data before it was pushed into the legacy SQL table. And part of that process is when you get the data back from ArcGIS Online, in that version data, you'll see you have to change versions to that user's version. Then you have to go through the reconcile, post the data, and then you have to delete the data. In addition to that, you have to stop all the ArcGIS services. And then once all that is done, then you can perform the compression. And the compression pushes the data through the delta tables into the base table in GIS, and at that point the triggers fire and push the data over to SQL. So it's a lot of stuff happening, but it all works. It all works. And just a screenshot, of the again, this is dummy data, but it just shows the data coming back as an iPad user from the field, and they collected a couple wells. You change the version to the iPad user, you do your QA/QC, and then you can reconcile that data to the database and post it. Whoops, excuse me. Once you do that, here's the reconcile version. This was, I think, a couple versions back on the tool actually, but gives you an idea. You're just using the tool script here to do that reconcile and post stuff. And then once you're done doing all that with the GIS data that came back from the field, all those iPad versions, you want to delete all those before you run that compression. Get those out of the way once you're satisfied with your QA/QC process. And all the costs and the benefits to this. Well, the big benefit was no more paper forms. So, and it also reduced the need to use that Access front end. And that really saved a lot of time. One thing we also learned was the field crews are, they're all tech savvy now. Everybody has a smartphone, whether it's an iPhone or Android or whatever it might be, and they like using these kind of tools in the field. They picked it up really quick, and they were, I think the field crews were really bought into this data collection methods. Another cool thing about it too was the comment field. If you're in good conditions, it's just like I have an iPhone, you can put the microphone button on and just speak into a comment field and populate a comment field, so that was really cool. And the field staff also got to do other things also. So they got to learn ArcGIS Online, they got to learn how to do edits, simple edits on ArcGIS Online before the data was posted. So they gave them that experience too, which was a real benefit to the company. Another good thing was that the data being collected, since it was directly into a database, allowed ArcGIS web services to be utilized to, to get data to a client. Other offices can view data, view the information, or you can use it for presentations. But again, all this comes at a cost. So when you start adding in all the Esri licenses and maintenance fees, you have to pay for all the technology you have to use. You have to have standard and advanced licenses for dealing with SQL databases. Server Enterprise is a big cost. The Microsoft SQL Enterprise, there's a cost associated with that. Then the technical staff to run all this stuff. You have to have people that understand databases. You have to have a strong, solid IT support, and then the GS, administration of that database and equipment. And lastly, the moral of the story is solutions do exist. I know we sweated it out for a while there when we first got to that primary key constraint, and that happened right off the bat too. So it was one of those things, like, oh boy, here we go. And if you think about what you're doing and what the end results need to be, there's always, in GIS, there's always a way around something. There's always 2 or 3 ways to do something. In your case, it only took you 2 days to figure it out. I think in our case, that solution took a couple months to put together. It's a little bit more complicated, and at least for us. It also highlights the needs really to, kickoff meetings. We have those, but I like to have what they call scrums. You could have daily or weekly scrums. You really need to get together more often. They have Scrum Masters. You can get that certification now. They teach people actually how to organize these, on-the-fly groups. So when you're working on a project, you're talking, you're communicating more often, you're looking at problems, and that's more like an Agile Development environment. And I kind of favor that a little bit sometimes, just because it gives you, additional flexibility in engaging the project participants a little more frequently, and get those discussions a little more often, rather than waiting to, in this case, this project, they were kind of doing the waterfall approach. They went and did all the migration of each of these databases to SQL, and it was like a chunk of data done first before the people were really engaged in the project. And so in the Agile Development, I think it gives you a little bit more early detection of potential issues. And I think that's all I got. There's my only slick slide I have right there.